All right, in this video, we're going to use the conjugate radical, okay, to rationalize the denominator or numerator of a rational expression, okay? So you're going to use this later on in this class when you need to rationalize a numerator or denominator. Okay, you can do that with trig functions. You can do it with limits when you get into calculus. A lot of different places you can use that concept of rationalizing the denominator or the numerator. Now, it's a little bit different than what we did with the basic radicals when we were rationalizing the denominator earlier in the class, okay? So a little bit different because this is a conjugate radical being used to rationalize, not just multiplying by the exact radical expression that was there before, okay? So if a denominator, which is most common, or a numerator, which is less common, okay, when we're rationalizing, you're most often going to do it with denominators, but you'll do it a fair amount with numerators as well, okay? It has to be a binomial. Okay, and one of those terms that make up the binomial has to be in radical form. Okay, could be a sum of these two terms, could be a difference of these two terms. All right, we're going to change the sign, whatever it may be. We're going to change the sign, and we're going to multiply by that binomial. Okay, so the conjugate radical, if the denominator or the numerator is of the form a plus b radical c, then the conjugate radical is of the form a minus b radical c. Okay, whatever this sign is of the first radical, or the first binomial in the problem, we're going to change that sign. Okay, so if this was a minus b radical c, we would multiply by the conjugate radical of a plus b radical c. What that does, these two binomials create that sum and difference of two terms. Okay, and that's a special pattern that we learned in the previous section, okay? And you'll see what happens when we multiply by this conjugate radical, all right? So number one, we're going to rationalize the denominator, and in number two, we're going to rationalize the numerator, okay? So my expression here, this rational expression, I've got 2 divided by this difference, y minus y radical 5, okay? For whatever reason, I may want to rationalize the denominator, whether I'm verifying trig identities, whether I'm trying to apply limits in calculus. You know, there's multiple times where you might use this process. So what I want to do is I want to multiply both top and bottom. Oh, excuse me. Oh, I'm going the wrong way. I want to multiply both top and bottom by the conjugate radical here. So again, we're going to change that sign in the middle. Okay, so I'm going to multiply the numerator by y plus radical 5. I'm going to multiply the denominator times y plus radical 5. Okay, so in the numerator, I'm going to get 2y plus 2 radical 5. Okay, in the denominator, what happens, remember, this is a sum and difference of two terms. So what happens when I use the distributive property, the two middle terms would cancel out. So what I end up with is y times y, which is y squared, and negative radical 5 times positive radical 5, which is negative 5, okay? So you can see our denominator here doesn't have any radical expressions anymore. We've rationalized that denominator. My radical expression is now in the numerator, okay? In certain instances, maybe when we're, again, trying to figure out the limits of certain functions, you'll need to use this pattern, all right? When we're verifying identities, there's other times where you can use this, but those are two examples that come to mind right away, okay? But then it's just using the distributive property to clean this up. And if you can remember that special pattern that we learned earlier, it'll make it easier, okay? Now, in certain cases, maybe you want to rationalize the numerator, all right? So we need to understand here that this expression is over and understood 1, okay? So when I rationalize, remember the conjugate radical is going to be change the sign, it's going to be the difference of those two terms. Okay, so it's going to be radical x plus 1, which was my first term, radical x, which was my second term. It was positive. The conjugate radical has to have the opposite sign, so this will be negative. And I'm going to multiply both numerator and denominator by that conjugate radical. Okay, now, in the numerator, remember, I have a binomial times a binomial. No matter how ugly those binomials may look, the pattern remains the same. Multiply this term by itself, okay? A radical expression times itself, we just get what was underneath that radical. So that's going to be x plus 1. Okay? Minus, because we've got a positive radical x and a negative radical x. So when I multiply these two terms together, I get minus x. Okay? And then in the denominator, I've just got 1 times my conjugate radical, so it's going to stay the same thing. All right. So notice we've rationalized the numerator now. We do have some like terms that we can combine. I've got x here minus x, so those cancel out. So my numerator is just going to be 1 divided by what was my conjugate radical. Square root of x plus 1 minus square root of x. Okay. We're not worried about domain here for now. We're just worried about using the conjugate radical to rationalize either the numerator or the denominator. All right. Watch this video a couple times. I think you might need to watch this one a couple times to understand what's happening. But we want to be able to rationalize either half of that fraction based on what our needs may be.